So again, welcome back to ExamDost. Welcome back to ESE Officer Series for solving previous year question of engineering services. So we are live in the fourth session of electric circuit. So come on everyone, join quickly everybody. We are about to start solving the PYQs of electric circuit in our fourth session. So in the previous session, I demonstrated the PYQs of transients, and now is the time to talk about the AC circuits. Okay. चलो 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 भाई. Come on everybody. चलिए. Shall we get started? चलिए. The capacitance C of the given AC circuit to make it a constant resistance or for the supply circuit to be independent of frequency. ESE 2001. What is the value of C for the circuit to be independent of frequency? Now remember, independent of frequency condition is so C is 1 by 16. C is 1 by 16. Next. For the circuit shown in the figure, the current flow through L and the voltage across C2. What is the voltage across C2 and the current flowing through the L? Come on everyone. RRB JEE batch, beta, RRB JEE batch is already available on our website by the name Rajdhani batch. So this is a DC source, capacitor open, inductor will be short. So my current will go like this. Like this. So the inductor current will be equal to I and capacitor voltage will be equal to IR. Capacitor voltage IR. D option. Next. A parallel circuit consists of two branches. One branch has RL and L connected in series. Other has RC and C connected in series. The two branch will be in quadrature if RL RC is equal to L into C. 1 minute, not L into C, L by C. Impedance is independent of frequency if RL equal to RC and omega is 1 by root LC. The circuit is in resonance for all frequency if RL equal to RC. The two currents will be in the same phase at omega equal to 1 by root LC. ESE 2002 beta. Come on everybody. Quickly. दिवाकर भाई हो सकता है तुमने मार्क फॉर रिव्यू कर रखे हो वो काउंट हो गए हो. ठीक है, एक बारी अगर आप मॉक टेस्ट देके देखते तो आपको आइडिया लगता ना. चलिए ये बताइए. और मेरे बच्चे मेरे हाथ में थोड़ी ना है कैंसिल कराना. ऐसा थोड़ी मैं वीडियो बना दूंगा तो आरआरबी वाले देख के कैंसिल कर देंगे. चलिए, let us see बेटा. This is my voltage. The current in the inductive branch will lag. It will lag the voltage by phi 1. Okay. The current in the capacitive branch will lead. Okay. This is the impedance angle. So quadrature means that the two currents are at 90 degree. Quadrature means that the two currents are at 90 degree. So take tan on both sides. Tan 90 minus theta is cot theta. So first statement is correct. RLRC is L by C. RLRC is L by C. The impedance of the whole circuit is independent of frequency if RL equal to RC and omega is 1 by root LC. Now let me talk about the admittance. First of all, let me talk about the admittance. Because two branches are in parallel, we must approach by admittance. I am rationalizing. Omega L. Okay. So now beta, at resonance, the imaginary part will be 0. At resonance, my imaginary part will be 0. So omega L. So omega will get cancelled. Now what I can say? Omega C. Okay. RC square C square L. L square C square, or if I take L square C. LC means C will common, LC means L will be here. ठीक है. L plus omega square. Now beta, if RL equal to RC, अगर RL RC बराबर होंगे, these two term will get cancelled out. Omega square is 1 by LC. 1 by root LC, तो रेजोनेंस तो आ गया. So this is correct, this is correct, this is incorrect. Not at all frequency omega is 1 by root LC. The two currents will be in phase at omega equal to root 1 by LC. Omega equal to root 1 by LC. देखो दोनों करंट सेम फेज में तो वैसे भी नहीं आ सकते, एक लैग होगा एक लीड होगा. The two can not be in same phase. One current has to be leading, other has to be lagging. Okay. रुकिए. तो इसमें स्टेटमेंट जो करेक्ट होगी बेटा, द करेक्ट स्टेटमेंट्स आर 1 and 2. The correct statement should be 1 and 2 because the two currents cannot be in the same phase. One will always be lagging and the other will always be leading. Okay. So the answer should be 1 and 2. Clear हुआ? बेटा मैंने बता दिया, अगर आरआरबी का बैच लेना है राजधानी बैच के नाम से, सभी एजेई का बैच लेना है विद्युत बैच के नाम से, आप वेबसाइट पे जाके परचेज कर सकते हो. तो बेटा सभी की सेपरेट प्लेलिस्ट है, हर सब्जेक्ट की अलग अलग होगी. और वैसे तो 30-40 वीडियो ही तो है, हर सब्जेक्ट की 5-5 6-6 वीडियो की क्या प्लेलिस्ट अलग अलग बनाए. अगर ईएसई पीवाईक्यू की एक प्लेलिस्ट भी है तो भी ज्वाइन कर लोगे. हाँ, जेके एसएसबी का भी बेटा बैच है हमारे पास, वो आप परचेज कर सकते हो. काफी बच्चे तो ऑलरेडी कर चुके हैं, मेरे को लग रहा है काफी, मतलब आप लेट जागे हो इस एग्जाम के लिए. ठीक है, तो इसका आंसर शुड बी ए. जस्ट अ मिनट. करेक्ट आंसर शुड बी ए. ठीक है, द आंसर शुड बी ए. चलिए नेक्स्ट वन. At resonant frequency, a RLC series circuit draws maximum current due to the reason that. Why does the circuit draw maximum current? बताइए. Because XL minus XC is 0. So mod of impedance is minimum, current is maximum. Okay. IR in ampere is equal to, at resonance, what is IR? ESE 2002, what is IR at resonance? Come on everybody. IR will be 5. Entire source current flows through R. Now, next, consider the following statement about the quality factor. For a critically damped circuit, quality factor is half. Higher the value of quality factor, higher will be the bandwidth. Higher the value of quality factor, lower will be the bandwidth. For undamped circuit, quality factor is, underdamped quality factor is greater than half. अब देखिए क्या होता है ना, or let me write like this. Quality factor is 1 by 2 zeta actually. So critically damped means zeta equal to 1, quality factor will be half. So higher bandwidth wrong. Higher quality factor, lower bandwidth yes. Quality factor greater than half means zeta less than 1. तो ये भी सही है. 1, 3, 4. Answer should be D. Okay. क्वालिटी फैक्टर हाफ से बड़ा माने जीटा 1 से छोटा आएगा. इट विल बी अंडर डैम्ड. In a series RLC circuit, current is maximum at resonance. Maximum voltage across capacitor occurs at a frequency less than resonance frequency. बताइए. Assertion reason. In a series RLC circuit, current is maximum at resonance. ऐप पे क्रैश कोर्स नहीं है फॉर जेई. है बेटा, विद्युत बैच के अंदर है. जेके एसएसबी के अलग बैच के अंदर नहीं होगा जहूर भाई. तो आंसर इज बी. एट रेजोनेंस एक्सएल इक्वल टू एक्सी, सो योर करंट इज मैक्सिमम बट वीसी इज मैक्सिमम एट अ फ्रीक्वेंसी लेस देन रेजोनेंस फ्रीक्वेंसी. तो वीआर इज मैक्सिमम एट रेजोनेंस, VL is maximum at omega greater than omega naught. VC below resonance. Okay. चांसेस तो हैं बेटा ओबीसी कैटेगरी में 97 मार्क्स से. ESE 2004 for a parallel RLC resonant circuit, damped frequency is rooted, bandwidth is 2. What is the resonance frequency? What is the resonance frequency? ESE 2004 beta. Damped frequency is given, bandwidth is given. What is the resonance frequency? देखिए डैम्ड फ्रीक्वेंसी इज alpha is 1 by 2 RC. Okay. Now bandwidth is 1 by RC. Therefore alpha is 1. So answer is 3 radian per second. ठीक है. Answer is 3 radian per second. Next, ESE 2004. Consider the following circuit. Current source is sinusoidal with a frequency equal to resonant frequency. What is the current through the resistor? The source frequency is equal to resonance frequency. What is the resistor current? बोलो भाई. What is the current through the resistor? The circuit is under resonance. Resistor current is equal to I. Because the entire current will flow through the resistor. It is I. In AC series RLC circuit, voltage across R and L is 20, L and C is 9, RLC is 15. What is the voltage across C? अब ये देखिए ESE 2004 का ये क्वेश्चन है. देखिएगा The voltage across R and L is perpendicular. Voltage across L and C is opposite, but we don't know which value is bigger. ठीक है, we do not know which value is bigger. Either VC is bigger or VL is bigger. The total voltage is like this. VR is 12. VL is 16. Okay. Now, there can be two cases. VL is 16, so VC is 7. Only one option matches 7 volt. ठीक है, ये अपने को फेजर डायग्राम से सोचना होगा. VR and VL are perpendicular, so their resultant is under root A square plus B square. VL, VC are opposite. So mod VL minus VC and VR is perpendicular to VL minus VC. बेटा ECE का पेपर मैंने देखा नहीं है शिवम, तो I cannot directly comment बेटा. A circuit has two parallel branches. In one branch R and L are in series, while in other R and C are in series. If R equal to under root L by C, which is correct? ये C आएगा कि अगर R रूट L by C हो गया ना, where RL equal to L by R equal to RC, तो R equal to रूट L by C. तो देखो इस कॉन्सेप्ट पे ना काफी सवाल दिख रहे हैं ESE के अंदर. ये जो दो ब्रांचेस लगा रहा है, एक RL सीरीज एक RC सीरीज. In this concept we have seen at least 2-3 question out of just 11 questions. So that is why this is very important concept. Remember this for ESE. कलेक्टर करंट यार देखो, जब बेस से माइनॉरिटी कैरियर कलेक्टर में जाते हैं तब तो मेजॉरिटी कैरियर ही बन जाते हैं ना, इस वजह से वहां पे मेजॉरिटी उन्होंने दिया है. अगर आप वैसे सोचोगे तो बेस से माइनॉरिटी कैरियर्स आ रहे हैं, बट इन कलेक्टर दे विल बी कॉल्ड एज मेजॉरिटी कैरियर. चलिए, ESE 2005 for a series RLC, what is total reactance at half power frequency? At half power frequency, what is the total reactance? So beta, at half power frequency, this is the condition. So at lower half power frequency, capacitor dominates. XL minus XC is minus R. So answer is D. ठीक है, ये कब आएगा? At upper half power frequency. CB2 टू शिफ्ट 1 में माइनॉरिटी, वो बेटा रिवर्स सैचुरेशन करंट को माइनॉरिटी बोला है, और नॉर्मल करंट तो बोला है ना मेजॉरिटी प्लस माइनॉरिटी. मिनिमम होता है पावर फैक्टर नो लोड पे. इन अ सीरीज RLC सर्किट द मैक्सिमम वोल्टेज अक्रॉस कैपेसिटर ऑकर्स एट अ फ्रीक्वेंसी, I just now told you, below the resonance frequency. Below the resonance frequency. A series RLC circuit excited by a 100 volt variable frequency source has a resistance 10 ohm, reactance 50 ohm. If the resonance frequency is 500 Hz, what is the capacitor voltage at resonance? बताइए. Resonance frequency is 500 Hz. What is the capacitor voltage at resonance? मिनिमम कैसे होगा? क्योंकि नो लोड करंट में रिएक्टिव पावर ज्यादा होती है ड्यू टू मैग्नेटाइजिंग करंट। नो लोड पे रियल पावर कहां से आएगी? सिर्फ लॉसेस ही तो हैं, लोड तो है ही नहीं रियल पावर लेने वाला, तो रिएक्टिव पावर डोमिनेट करती है, पावर फैक्टर लो होता है। चलिए बेटा, एट 100 हर्ट्ज XL is 50 ohm. Now XL is proportional to frequency. So at 500 hertz, capacitor voltage at resonance is QVS. So answer is C. That is why quality factor is called magnification factor. चलिए next. Consider the following statement if a high quality factor parallel resonant circuit is loaded. Okay. Parallel circuit. Now you connect RL across it. आपने एक लोड रेजिस्टेंस लगा दिया तो R equivalent decreases, bandwidth 1 by RC increases, resonant frequency is constant, circuit impedance decreases. तो आंसर इज बी। ऐसा क्वेश्चन मैंने प्रीवियस सेशन में भी कराया था। impedance will reduce when you connect something in parallel, bandwidth will increase and omega will be constant. चलिए नेक्स्ट। For a series resonant circuit, which of the following are the impedances at lower and upper half power frequency? Impedance, not reactance. तो ESE 2007 अभी अभी आपने reactance का क्वेश्चन किया था। Now it is talking about impedance. Impedance बेटा। तो at half power frequency, just now I told you, mod of XL minus XC is R. Root 2R. At lower power, lower half power frequency, capacitor dominates. At upper half power frequency, inductor dominates. B. So answer is D. Okay. And why is the angle 45? Because reactance is equal to resistance. From here we can say tan phi is 1. So phi is 45 degree. Okay. When x equal to R, the angle is 45. When is a series RLC circuit overdamped? What is the condition of overdamp? That is alpha greater than omega naught. So answer should be A. ठीक है, आंसर शुड बी ए। इट हैज स्क्वायर्ड बोथ द साइड, दोनों साइड का स्क्वायर कर रखा है। In a RLC series resonant circuit, maximum stored energy is increased by 10% and energy dissipated is reduced by 10%. तो क्या होगा बताइए? What will happen? Maximum stored energy is increased by 10% and energy dissipated is reduced by 10%. हाँ बेटा, सेकंड शिफ्ट वालों के लिए मैं सेशन लूंगा। बेटा एक काम करो सुमित, मेरा लेक्चर आप एक बार देख लो बेटा, इंडक्शन मशीन का यूट्यूब पे ही पढ़ा होगा, आपको ये सारे डाउट क्लियर हो जाएंगे कि वो R21 माइनस एस बाय एस क्यों लेते हैं। ठीक है। और अगर ये आरआरबी का सवाल है तो आरआरबी का शिफ्ट 1 का पेपर मैं आज डिस्कस करूंगा अबाउट ऑब्जेक्शन। देखिए क्वालिटी फैक्टर इज 2 पाई इंटू मैक्स एनर्जी स्टोर्ड by energy dissipated per cycle. Now, if the maximum stored energy is increased by 10%, so it will become 1.1, and energy dissipated is reduced by 10%, so it will become 0.9. So 11 by 9, 2.22 Q1. So quality factor will increase by 22%, sorry 1.22. समझे? 10% बढ़ना माने 1.1 टाइम्स होना, 10% घटना माने 0.9 टाइम्स होना. For a parallel RLC, if R equal to L equal to C, bandwidth and quality factor. Come on. ESE 2010, bandwidth and quality factor. For parallel RLC, what is the bandwidth? 1 by RC. Quality factor, R root C by L. C. 0.05 and 20. Next, in a series RLC circuit resonates at 1.5 kilohertz and consume 100 watt from a 100 volt AC source operating at resonant frequency with a bandwidth of 0.75 kilohertz. The value of R, L and quality factor are. Try कीजिए ESE 2010 series RLC resonant circuit resonance frequency is given, real power is given, bandwidth is given, R, L and quality factor. So quality factor is F naught by bandwidth. तो आंसर तो यहीं से डिसाइड हो गया ए. नाउ पावर. Series RLC circuit will be entire Vs. Source voltage appears across R. At resonance, the total supply voltage appears across R. So R will be 100. Correct? R will come out to be 100. And what about L? Bandwidth. R by L. Hmm. 0.75 kilohertz. R by L आता है इसका bandwidth. 1500 पाई. 100 by 1500 पाई. 1 by 15 पाई. तो आंसर विल बी ए. ठीक है, ए आ गया. Next, the resonant frequency of a RLC series circuit 1.5 megahertz, resonating capacitor 150 picofarad, bandwidth 10 kilohertz. What is effective value of R? R का वैल्यू बताइए. क्रैश कोर्स बेटा मैंने YouTube पे डाला हुआ तो है जहूर, तो आप पेड में क्यों मतलब सेम कोर्स देखना चाह रहे हो? क्रैश कोर्स इज ऑलरेडी देयर ऑन YouTube, वहां से देख लो. Bandwidth, resonance frequency, capacitance is given. I need resistor. बताओ भाई क्या आएगा। अब देखो यहां पे कोई शॉर्टकट नहीं है, so from here we have to calculate the value of L. $75 microhenry. Now R by 2 pi L is bandwidth. अब देखो कुछ बच्चे बोलेंगे R by L होता है बेटा, तो यूनिट्स का ध्यान रखें. Bandwidth is R by 2 pi L if it is in hertz, and it is R by L in radian per second. 75 microhenry. 0.75, 1.5 pi. So almost 4.7. D. Answer will be 4.7. For a series RLC circuit energized with a sinusoidal source of frequency 4 radian per second, the voltage lags the current by tan inverse 2. What is the value of R? At 4 radian per second, what is XL? What is XC? 5. Okay. Now tan inverse XC minus XL by R. Voltage is lagging the current ना, it means current leads the voltage. वोल्टेज करंट से लैग कर रहा है, इसका मतलब है करंट आपका लीड कर रहा है. R is 0.5 ohm. D. R will be 0.5 ohm. Next, again ESE 2010. A step voltage is applied to a underdamped series RLC circuit in which R is variable. If R is increased, the steady state voltage across capacitor will be reduced. बेटा ये क्या है? ये एक डीसी सर्किट है. This is not AC circuit. So steady state voltage across capacitor, under steady state capacitor will be open supply. So this option is wrong. Increase because frequency of transient oscillation will be reduced. Wrong again. Reduce transient oscillation will die out at a fast rate. If R is increased, frequency of transient oscillation are reduced. Just a minute. If R is increased, frequency of transient oscillation तो R इंक्रीज होने से फ्रीक्वेंसी ऑफ ऑसिलेशन डिक्रीज होती है. ठीक है, दिस इज करेक्ट. अगर R रिड्यूस होगा तो ऑसिलेशन विल डाई आउट एट अ फास्ट रेट. अब अल्फा इज R बाय L, तो R decreases, alpha decreases, which means damping decreases. If damping reduces, oscillations last longer. Oscillation लंबा चलेंगे बेटा, damping जितना कम, oscillation last longer. Okay, so this is wrong. Reduce to zero. अगर R को zero किया, capacitor peak will be double the input voltage. This is correct. This will now become a LC oscillator. If you make R equal to 0, this will become a LC oscillator. Capacitor voltage will be Vs 1 minus cos omega t. So at omega t equal to pi, Vc equal to 2 Vs. अब if you are doubting, sir, how you have written the equation of Vc, for that you have to watch the lecture based on LC oscillator. मैंने LC oscillator में ये सब equation लिखना सिखाया है. Okay? For a parallel resonant circuit, if the damped frequency is √8, this is repeat. This is repeat. ये मैं करा चुका damped frequency और bandwidth वाला question. This is repeat. Correct. Network function TS, resonant frequency and bandwidth are. आपको मैंने function दे रखा है. What is the resonant frequency and bandwidth? Now बेटा, remember denominator should be like this. The denominator of such a function should be like this. So compare. Omega naught square is 100. Omega naught is 10. Omega naught by quality factor is 2. So quality factor is 5. Okay. 10 by 2, 5. And bandwidth? So 10 and 2 na? Resonant frequency and bandwidth 10 and 2. Okay. This omega naught by Q is actually bandwidth. ये bandwidth होती है. Okay. ये अच्छा concept है, याद रखिए. For the parallel RLC circuit, RLC is given, current I is equal to the resonant frequency. This also we saw. This is also repeat. तो आप देख सकते हो in ESE sometimes the PYQs directly repeat. बहुत बार PYQ directly repeat हो जाते हैं बेटा. A network is said to be in resonance when the voltage and current at the network input terminals are in phase. In a two-terminal network containing at least one inductor and capacitor, resonance is defined as the condition in which input impedance is purely resistive. तो सही explanation दे रहा है बेटा, क्योंकि at resonance the impedance is purely resistive. That is why current and voltage will have the same phase. क्योंकि ऐसा बोला जा रहा है कि impedance purely resistive है, इसीलिए same phase आपका बनेगा. हाँ भाई, आज ऑब्जेक्शन क्वेश्चन वाला सेशन तो है, जाके देखो तो सही अमर भाई होम पेज पे. A series RLC circuit has a resonant frequency F0. RLC is given. If component values are tripled, what is the new resonance frequency? If all component values are tripled, what will happen to the new resonant frequency? तो बेटा गलत दिया हुआ है, और क्या तरुण भाई? F0. Now component values are tripled. So 3 will come out common. It is F0 by 3. ठीक है, 3 कॉमन आ जाएगा. It will be F0 by 3. हाँ भाई, बेसिक से ही पढ़ाएंगे. बाकी मैंने बताया है, जो पिछला वीडियो मैंने लिया था सैटरडे को, उसमें मैंने आपको बताया कि आप कैसे उसके साथ और क्या क्या चीजें कर सकते हो. क्वालिटी फैक्टर और सिलेक्टिविटी का फॉर्मूला फॉर अ सीरीज रेजोनेंट सर्किट. व्हाट इज द फॉर्मूला? 1 by r root L by C, not C by L, L by C. For a series RLC circuit in resonance, the following statement is not correct. Current is maximum. Yes. Phasor across VL and VC are unequal. No, they are equal. That is why they get cancelled. Voltage drop across resistance is maximum. Yes, VR is VS. Voltage drop across, I think this is correct. Phasors are opposite. That is why you can say they are unequal, but magnitude are equal. ठीक है, तो D हमें चुनना चाहिए. मैग्नीट्यूड इक्वल होते हैं, फेजेस तो अपोजिट ही होते हैं बेटा. So phasors you can say are unequal, but the magnitude will be equal. Chaliye, the circuit given below is constituted by a iron core coil and a capacitor. At resonance, the circuit behaves like at resonance. What is the behavior of this circuit? The answer will be D. So this is called as the practical tank circuit. So at resonance, the impedance of this circuit is L by RC. Okay, L by RC. Is that clear? So that is much higher than R. So this is very high. The given network will act as the ideal current source with respect to X and Y. If the frequency is, it will act as the ideal current source. If the frequency is, so at resonance, it will become an ideal current source. तो आंसर इज 1/2 पाई. सर इसके पीछे लॉजिक क्या है? देखिए, आई विल डू सोर्स ट्रांसफॉर्मेशन. ठीक है, आई विल डू सोर्स ट्रांसफॉर्मेशन. तो बेटा एट रेजोनेंस parallel LC oscillator acts as open circuit. So this will act as open at resonance. So my load current is same as supply current. So then it will become an ideal current source because this parallel circuit will act as open circuit. ठीक है, चलिए. In a linear network, 1 ohm resistor consumes the power of 4 watt when 4 volt is applied, 16 watt when 8 volt is applied, power consumed when 12 volt is applied. बताइए. फोर वोल्ट पावर इज 16. I1 is 4 ampere. Eight volt. Sorry, 4 watt. Okay. Now at 12 volt is 8 volt plus 4 volt. So by superposition, current will be 2 plus 4, 6. Power I square R 36 watt. Answer will be C, 36 watt. ठीक है, 36 watt. A series RLC circuit has a bandwidth 300, resonance frequency 3000, voltage source 100 volt. L is 0.1 R and voltage across C. अब now beta, this is ESE 2013. At resonance, VC equal to VL equal to QVS bandwidth is R by L. Now quality factor is omega L by R. या क्वालिटी फैक्टर ऐसे निकालो ना सीधे सीधे, ओमेगा नॉट बाय बैंडविड्थ थाउजेंड. तो R is 30, VC is 1000. सी ऑप्शन. ठीक है, बेसिक फॉर्मूला बेस्ड क्वेश्चन आते हैं रेजोनेंस से. The circuit comprises a coil of resistance R and inductance L in parallel with the ideal capacitor C. बेटा अगर बैंडविड्थ हर्ट्ज में है तो इट इज R by 2 pi L. If the bandwidth is in radian per second, it is R by L. तो बेसिकली 2 pi into hertz becomes radian per second. ठीक है, या रेडियन पर सेकेंड से हर्ट्ज में जाने के लिए यू हैव टू डिवाइड बाय 2 पाई. दैट इज व्हाई व्हेन आई एम राइटिंग बैंडविड्थ इन हर्ट्ज आई एम डिवाइडिंग बाय 2 पाई. आई एम कॉलिंग इट एज R upon 2 pi L. हाँ जी. सर्किट हैज अ कॉइल ऑफ R and L in parallel with C at resonance frequency combination is, ये अभी मैंने बताया था बेटा, प्रैक्टिकल टैंक सर्किट. यू कैन रिमेंबर दिस, एंड दिस वैल्यू इज मच ग्रेटर देन R. This value is much greater than R. C. In RLC circuit, the current at resonance is, RLC circuit में resonance पे current कैसा आता है बोलिए भाई. Very good तमन्ना बेटा. What is the current at resonance? It is minimum in parallel and maximum in series. क्योंकि in series circuit at resonance impedance is minimum. At parallel circuit impedance is maximum. Again ESE 2013, RLC are connected in parallel, the impedance of parallel combination. Now for parallel it is always better to go with admittance rather than impedance. So S square by 10S, S by 10, S upon 10S, 1 by 10, 400 by 10S, 40 by S. So the value will be 1 by R, 1 by SL, SC. So R equal to 10, L 1 by 40, C 1 by 10. ठीक है, 10, 1 by 40, 1 by 10. C option. ठीक है. During resonance, a RLC circuit behaves as a purely resistive. During resonance in a RLC series circuit, the voltage across L and C are in phase with each other. L और C का वोल्टेज सेम फेज में आता है. बोलिए, what is correct? First statement is correct, second is false. Voltage in opposite phase. Voltage in opposite phase. Next, a RLC resonant circuit has a frequency 1.5 megahertz. ये वाला भी रिपीट है, देखिए. Same question has been repeated in ESE 2014. The answer is 4.7 ohms. In a series resonant circuit, maximum voltage across inductor occurs at, कौन सा क्वेश्चन नंबर बोलो राकेश भाई, कौन सा समझ नहीं आया? ये वाला कह रहे हो? तो बेटा इंपिडेंस दे रखा है. पैरेलल में क्या निकालते हैं हम? एडमिटेंस निकालते हैं ना. तो इन पैरेलल एडमिटेंसेस आर एडेड. तो पहले मैंने इंपिडेंस का रेसिप्रोकल करके एडमिटेंस लिख लिया, ठीक है। ये 10s डिनोमिनेटर हो जाएगा ना, एक एक टर्म को डिवाइड कर दिया. नाउ इन पैरेलल ऑल एडमिटेंसेस आर एडेड. द एडमिटेंस ऑफ रेजिस्टर इज 1 by R, एडमिटेंस ऑफ इंडक्टर 1 by SL, एडमिटेंस ऑफ कैपेसिटर इज SC. देखो इंपिडेंस क्या होती है रेजिस्टेंस की R, सो एडमिटेंस इज 1 by R. इंपिडेंस इंडक्टर की होती है SL, एडमिटेंस इज 1 by SL. इंपिडेंस कैपेसिटर की होती है 1 by SC, सो एडमिटेंस इज SC. अब टर्म्स को कंपेयर कर लो बेटा, ठीक है, तो यहां से मिल जाएगा C, R और L. चलिए, हाँ जी, मैक्सिमम वोल्टेज अक्रॉस L ऑकर्स एट स्लाइटली अबव रेजोनेंट फ्रीक्वेंसी. ये मैंने बताया था ना, कैपेसिटर वोल्टेज मैक्सिमम बिलो रेजोनेंस फ्रीक्वेंसी, इंडक्टर वोल्टेज मैक्सिमम अबव रेजोनेंस फ्रीक्वेंसी, रेजिस्टेंस वोल्टेज मैक्सिमम एट रेजोनेंस फ्रीक्वेंसी. Quality factor of a coil at resonance frequency 1.5 megahertz is 150. Then the corresponding bandwidth is. Very easy question. Quality factor and resonance frequency is given. तो bandwidth अभी देखो मेरे को हर्ट्स में चाहिए राकेश भाई, तो हर्ट्स में चाहिए तो मैं एफ नॉट का यूज करूंगा तो मुझे हर्ट्स में मिलेगा, ओमेगा नॉट का यूज करूंगा तो मुझे रेडियन पर सेकंड में मिलेगा. 0.01 megahertz, that is 10 kilohertz. So in resonance topic, take care whether you are dealing with hertz or radian per second. The low frequency circuit impedance and high frequency are respectively. What is the nature of impedance at low and high frequency? Capacitive and inductive. So at omega less than omega naught, capacitor dominates. At omega greater than omega naught, inductor dominates. In a RLC series circuit excited from a variable frequency source, it behaves as resistive at a particular frequency. सही बात है, resonance पे. This is correct. At resonance, it will behave like a resistive circuit. The frequency at which it becomes resistive in character, a part of input energy oscillates between L and C. This is also correct. यहाँ पे एनर्जी L और C में ऑसिलेट करता है, बट इज द एक्सप्लेनेशन ट्रू? नहीं, बात तो सही कह रहा है, एनर्जी ऑसिलेट करती है L और C में, सर्किट आपका रेजिस्टिव हो जाता है, बट दैट इज नॉट द मेन एक्सप्लेनेशन. द मेन एक्सप्लेनेशन इज XL and XC gets cancelled out. So answer should be B. Next, in a series RLC circuit supplied by a source of 125 at resonant frequency 220, magnitude of inductor capacitor voltage is 4150, resistance is 1 ohm, selectivity. तो बेटा selectivity is nothing but quality factor. क्या होता है ना, if your quality factor is high, the resonance curve is sharp. So it passes a lesser range of frequency. That is, it passes a narrow band of frequency. So it is very selective. So it is VC by Vs. At resonance, capacitor voltage is QVs. 125 into 8000. 33.4. So 33.2. ठीक है, 33.2. Clear? A series RLC circuit is connected to a 25 volt source of variable frequency. Current is maximum of 0.5 ampere at 400 hertz. Capacitor voltage is 150. R और L बताना है. तो current is maximum at when? At resonance. And what is the value of current at resonance, beta? Current at resonance is V by R. So R will be 25 by 0.5, 50. Now quality factor वोल्टेज अक्रॉस सी दे रखा है, आर और एल पूछ रहा है, ऐसे कर लो देखो। एट रेजोनेंस वी एल इक्वल टू वी सी इक्वल टू 150, तो आई इंटू ओमेगा एल इज 150, what is omega? 2 pi into frequency, 300 by 400, 3 by 8 pi. तो 3 by 8 pi, 3 by 24.1 सी आ जाएगा, ठीक है। 3 by 8 pi is 0.1 approximately. What is the resonant frequency? इसका रेजोनेंस फ्रीक्वेंसी डिराइव कीजिए बेटा। मेक इमेजिनरी पार्ट ऑफ इंपिडेंस इक्वल टू 0। इंपिडेंस का इमेजिनरी पार्ट 0 करके निकालिए। फाइंड द रेजोनेंस फ्रीक्वेंसी। दिस इज फ्रॉम ESE 2016, ESE 2016 क्वेश्चन। निकालो भाई। So the impedance will be J omega L R parallel 1 by J omega C. R by J omega C, R plus 1 by J omega C. J omega L ठीक है। Now you make imaginary part of impedance equal to 0. Omega L is omega R square C. Now L is 0.2, C is 1, R is 1. तो कैंसिल ओमेगा, L बस 0.2 है, C और R 1 है। तो ओमेगा विल बी 2. B option. Omega will be 2. Next, the two networks are connected in cascade shown in the figure. Equivalent ABCD constant are having C equal to 0.1 angle 90. What is the value of Z2? अब C का वैल्यू 0.1 एंगल 90 आ रहा है, so what is the value of Z2? इसको करने का मैं आपको एक इजी सा तरीका बताता हूं यहां पे, लेकिन डायरेक्ट मेथड एप्लीकेबल होगा क्या? इसको ऐसे सोच लो, अगर आप इसको ट्राई करना चाहते हो ना इजीएस्ट वे में, रेफर टू पावर सिस्टम। रिसीविंग एंड सी मॉडल, ठीक है। तो व्हाट आर द पैरामीटर्स देयर? 1 plus yz, z, then y, then 1, ठीक है। And if you want to derive it from the very basic, you need C. करेक्ट। जो लोग बेसिक से करना चाहते हैं, लेट मी शो यू अदर मेथड ऑल्सो। तो C is what? I1 by V2 when I2 is 0. So I2 is 0. So I1 will flow like this. ठीक है, तो V2 will be I1 Z2. तो C is 1 by Z2. और यहां से भी C किसके बराबर आ रहा है? Y के, which is 1 by Z2. दोनों तरह से जा सकते हो, which is basically 0.1 angle 90. So Z2 is 10 angle minus 90. Reciprocal. In reciprocal, angle becomes negative and magnitude is taken reciprocal. Magnitude का reciprocal होता है, angle negative होता है. So either you can go by the basic method, by the basic definition, or you can go by power system approach. A series RLC circuit has RLC connected across 100 volt supply, resonance frequency, and the current across resistor. So resonance frequency is 1 by root LC, 0.4 or 10 microfarad. (500 radian per second). Current is V by R, 100 by 52. ठीक है, easy, 502 ampere. Next, for the circuit shown in the figure, what is the value of C that leads to maximum power transfer to the load if L is 0.5 Henry? C का क्या वैल्यू होगा for which the power is maximum? ESE 2018. What is the value of C for which power is maximum? ESE 2018 problem. L is 0.5, R is 5. We need the value of C that causes maximum power transfer. देखो बेटा, for maximum power transfer, ZL equal to ZS conjugate. Now the source is a resistance. Source बस एक resistance है. This is ZL. Parallel होने की वजह से I will go with admittance. Omega is 10. Okay. Now beta, basically your impedance should be resistive. Okay. Therefore, imaginary part of impedance must be 0 or imaginary part of admittance must be 0. सोर्स एकदम प्योरली रेजिस्टिव है ना, तो ZL भी रेजिस्टिव आएगा. तो बेसिकली व्हाट आई कैन से 10C is equal to 5 by 50. तो C equal to 0.01 farad. C is 0.01 farad. खत्म. ठीक है. और फिर देखो बचेगा क्या, 5/50 एडमिटेंस आएगा 0.1, विच मीन्स इम्पिडेंस इज 10. इफ एडमिटेंस इज 0.1, इम्पिडेंस इज 10. निधि बेटा कौन से बैच में आप ज्वाइन हुए ये मुझे बताओ. In the network shown with IS1 5 ampere, IS2 10 ampere, VAB 120, IS1 10, IS2 5, VAB 15. What is the value of K to describe IS1 equal to K IS2 such that VAB is 0? So beta by linearity, VAB is a linear combination of the two sources. Okay. So if you solve these two equations, let me multiply it by 2. Then subtract. Minus 30, 15. Okay. Minus 60 or 75. Okay. Now VAB minus 6 IS1 plus 15 IS2 is 0. So IS1 is 2.5 IS2. So answer should be A. Okay, because this network is purely resistive. So basically this network is linear. So I have used the linearity property. In resonant circuit, the capacitor voltage or inductor current could be much lesser than the source voltage or current, and a large signal can produce a small output when resonance appears. In resonant circuit, the quality factor is defined as the ratio of inductive reactance and the winding resistance, which is a dimensionless parameter. तो क्वालिटी फैक्टर का डेफिनेशन दे रहा है और पहले में कह रहा है दे कुड बी मच लोअर बट दे कुड बी मच हायर. काहे? बिकॉज IL is QIS in parallel and VC is QVS in series. So quality factor is a magnification factor. It will increase the voltage and current, not decrease them. At off resonant frequency in a parallel resonant circuit. Off resonance means F is not equal to F0. It is not at resonance. The phase angle is greater than I think this should be 0. So at resonance, unity power factor at F not equal to F0, phi is greater than 0 degree. Next, an electric circuit with 10 branches and 7 nodes will have. Very easy. This is now graph theory. 10 branches, 7 nodes. Mesh will be B minus N plus 1, 4. So 4 loop equation. Correct? Now, what kind of a filter is this? How to find the filter? Put S equal to 0. S tending to infinity. So gain is 0 at both sides. So this will be a band pass filter. अगर दोनों तरफ गेन लो आता है तो बैंड पास, दोनों तरफ हाई आता है तो इट इज अ बैंड रिजेक्ट फिल्टर. So now gain is low at both end of the spectrum. Gain is low at low and the high frequency. So in between it will be non-zero. It is band pass. The incidence matrix of a connected graph is given below. The following statements are associated. Now, branches 2 and 3, they have the same entry. That is, leave at node 3 and enter node 4. So this is parallel. This is parallel. Branches 4 and 5 are in series. अब ये देखो, ये 5, ये 2 से निकल के 1 में, 2 to 1, this is 3 to 2. Voltage of branches 4, 5, 6 form an independent set. इंडिपेंडेंट सेट 3 ब्रांच का वोल्टेज, अगर देखो इसका हम ग्राफ बनाएंगे ना, branch 1 is going from 1 to 4, branch 2 from 3 to 4, branch 3 from 3 to 4 again, branch 4 from 2 to 1, branch 5 3 to 2, branch 6 3 to 1. So these two are in series. So only this statement is correct. Branch voltages independent set नहीं बनाती हैं. So answer should be 2 only. ठीक है? Your node voltages can form a independent set but not the branch voltage. अब देखिए, total number of branches is equal to B. Graph has n number of branches. The minimum number of line current. नेटवर्क की ब्रांचेस भी हैं, ग्राफ में n ब्रांचेस हैं. मिनिमम नंबर ऑफ करंट तो ग्राफ से ही आएगा, n. In an electric circuit, number of independent mesh is m, B is branch, n is the number of node. तो mesh कितनी होती हैं? B minus n plus 1. The meshes are simply B minus n plus 1. Correct? Two networks are said to be dual, ESE 2016. When can you say that the two networks are dual of each other? The loop equation of one network are analogous to the node equation of the other. एक में जो mesh analysis से equation बने, अगर वही equation दूसरे में nodal से बन जाए, तो that is duality. Branches are B, nodes are n, number of links. Branches minus twigs. This is same as mesh. हर लिंक जो है ना एक mesh क्रिएट करता है. Every link is responsible for creating one mesh. ESE 2017. A network graph with its tree shown by the firm lines is given in the figure. Fundamental cut set for branch 2. Fundamental cut set means only one twig, rest all are links. तो 2 के लिए किसको काट सकते हो? टू 6 7 8 1 2 3 4 5 तो नहीं, 2 3 4 भी नहीं, तो यही आएगा 2 6 7 8. ओनली वन ट्विग। यहां पे देखिए 2 ट्विग्स आ रहे हैं, यहां पे आपके बल्कि 5 ट्विग्स आ रहे हैं, and here also all are twigs. So beta, fundamental cut set can only contain one twig, not all twigs. Only one twig is should be there. Reduced incidence matrix. What can be a tree? अब देखिए, अगर इंसिडेंस मैट्रिक्स बनानी है, मेक सम ऑफ ईच कॉलम 0. टू मेक अ इंसिडेंस मैट्रिक्स वी नीड वन मोर रो by making sum of each column 0. So wherever the sum is 0, I am placing 0. Where sum is non-zero, I am making the sum 0. Now there are 4 nodes A, B, C, D. एक मिनट यार, यहाँ पे ना A+1 कर लेना, ये गलत दे रखा है। C2A, then D2A, C2B, B2D. Now what can be a tree? 2, 3, 5. No, this is a loop. 1, 2, 6. 1, 2, 6. This will again be a loop. No. 1, 2, 4. 1 and 4 will be a loop. No. 1, 2, 3. Yes, this is correct. Because a tree cannot contain a loop. Tree में loop नहीं बनना चाहिए. Next, consider the following statement for a network graph. BF is the fundamental tie set. BT and BL are the submatrix corresponding to twig and link. Now, tie set matrix में link part is always identity and order link क्रॉस लिंक या फिर B-1 क्रॉस, ठीक है, लिंक वाला पार्ट, और ट्विग वाला आइडेंटिटी नहीं होता. तो ट्विग इज नॉट अ यूनिटी मैट्रिक्स, लिंक इज नॉट अ रेक्टेंगुलर, इट इज अ स्क्वायर मैट्रिक्स. दिस इज करेक्ट. अगर ये ट्विग को कह रहा है, नॉट करेक्ट. ट्विग का रैंक होगा n-1. Twigs in a network are always n-1, तो आंसर विल बी डी. ठीक है, फंडामेंटल लूप मैट्रिक्स है बीटी एंड बीएल आर. बीएल आइडेंटिटी मैट्रिक्स अभी मैंने बताया, ट्विग वाली आइडेंटिटी नहीं होती. ये भी करेक्ट है. तो सी. अभी मैंने बताया ना, लिंक वाली आइडेंटिटी होती है, ट्विग वाली आइडेंटिटी नहीं होती. 8 branches, 4 loop, how many nodes are there? तो 4 equal to 8 minus n+1, so n is 5. Nodes are 5. Last question beta. All networks are made up of passive linear time invariant element are reciprocal. Passivity and time invariance do not guarantee रेसिप्रोसिटी ऑफ आ नेटवर्क. ठीक है, कह रहा है जो लीनियर है, पैसिव और एलटीआई है, वो रेसिप्रोकल होगा. ये सही बात है, गारंटीड है. अगर आपका नेटवर्क पैसिव है ना, तो इट विल बी रेसिप्रोकल. इफ द नेटवर्क इज पैसिव एंड इट इज लीनियर एलिमेंट, लीनियर एंड पैसिव नेटवर्क आर ऑलवेज रेसिप्रोकल. ठीक है, लीनियर और पैसिव दो कंडीशन ट्रू होनी चाहिए. टाइम वेरिएंट इनवेरिएंट से फर्क नहीं पड़ता है, ठीक है, but linearity and passivity, these two are important. So that's it बच्चों. I'll see you again tomorrow at the same time 11:30 a.m. and tomorrow will be the second last session of your networks or circuit analysis. Okay, from Thursday we will start with the machines. Okay, चलिए, so I'll see you again tomorrow at the same time. Thank you.